my name is Boris. I'm a developer advocate at Google. Basically, what I do is I work with developers like yourself in order to make you successful. And today, I'm going to talk of a few techniques that assist me in writing code, or essentially assist me in writing less code or less boilerplate code. First, a little bit about myself. As I said before, I'm developer advocate at Google. Before I joined Google, I used to be Android developer, Android consultant, and then I was Android architect. I'm kind of an Android and runtime junkie. That's why I'm here. And also, I blog at www.apisolutions.com. So, we want to talk about powerful APIs to generate code, especially the boilerplate one. Let's look at the following code. And you know, just one simple class, having one simple method, getting one simple string info parameter. However, this code is a smallish example of what can be a boilerplate code. Consider adding logs. Consider adding dependencies. Consider adding any other things or code that make you feel annoyed when you're developing your Android code. And the good news, we can do a lot of stuff around it. Let's start with our first way, which is to use custom annotations with the Java Poet library. How it's done? Pretty easy. All you have to do is to create your own annotation class, which is going by interface, and add all the lovely parameters, which by itself might be a boilerplate code, but at least the good news that you do it once. To have the annotation retention, which is to say Java that's going to be kept on the runtime, to keep the target for methods, and just for fun, I provided the default implementation. Now, let's add this annotation to our code. How we do it? Pretty easy. We just add our own annotation that we defined in previous slide on top of our methods. And for added bonus, we even don't have to implement all the parameters there. That's why I have one annotation on the top without an info parameter, and one annotation of the bottom with the info parameter. Okay, this is a little work. I lied. Here, in order to make our annotations run and work, we need to add some piece of code that will serve as an annotation processor. Essentially, what it will do is, using reflection, which is a Java technique for modifying code at runtime, we iterate over all the methods and see if you have an annotation, as you can see, custom method annotation. And if you had it, we can call our method, generate code with Java Poet, that we shall see shortly, in order to generate our own code. Isn't that cool? And let's see how we do it. Basically, Java Poet is a library that you can happily look after for generating Java code. It is developed by Square and some pieces from Google to provide the dynamic ability to create code. And let's see how do we build, if you recall, our boilerplate method, which is pretty easy. If you see, this is a private static void, generate code with Java Poet, getting the string info. Method spec is one of the objects of Java Poet. It has a very nice, fluid, builder-based API that, when I look at it, I really think how beautiful this API is. We just add modifiers, we add the return type, we add the parameter, we build it, because we have to tell the Java Poet engine that we are done. To make sure We started with a method, which is a boilerplate code method, and everything good in Java has to come inside classes. Let's define class. Also around 2 more method calls, and add the method descriptor from previous slide to our class. And hopefully we should be done. And that's correct. We just call the Java Builder API, wrapped it up with a package name, we build it, and essentially for the sake of the simplicity of the code, we just output this to system out. But for instance, you can happily write file, and then these files can be used as part of your build. Amazing. So, if we think a little bit deeply what we have seen in previous slides, we do created a custom annotation class. We did updated our class with custom annotation. We have done some work with reflection. And based on the values from annotations, basically we can do anything we want with a Java Poet. We can do, if I remember correctly, enums. I think it's supported from the last versions. We can create methods, glue it out to our classes. And of course, as an added bonus, we don't have to create one class. As my colleague Stefan noted before, a good object-oriented practice is make class do one thing, and one thing only. It makes it testable among the rest. Another thing that we can think literally about annotation processing, there are many pieces to glue together, which makes it a little bit investment. In the first place, there's an addition to our build system, because we have to go and to grab files and to build files and to glue them together from various places, but luckily we have Gradle, which makes it a little bit easier, like defining your own custom tasks. And as an added bonus, we need a Java C call. In order for the code to work on Android, we need to compile it. Because essentially what we do, we generate code. And then somebody has to compile it, and then it will go to our toolchain to become from class format to DEX format, and then finally make its way inside the APK. Okay, and now get ready for the red pill. We are going to do the same, but not in the Java class level, not in the Java level, but in class format. Who have worked with class format before? Who know what is class format? Okay, great. Small recap, how Java works. We take our Java code, usually something that ends with Java. We apply the Java C tool, which is essentially Java compiler. And the result are binary files that are then loaded into the JVM and executed. So let me tell you a little secret. Your JVM from desktop world, and also Android VM and ART systems, don't know Java. Really. Honest. They don't understand it. What they do know is the binary format. And for the most of developers, these binary formats, both class format and DEX format, which hopefully I have time to talk about, are sort of a black magic for developers. And I hope that you are here because you want to understand it more. So this will not be your magic. You will be the masters. And let's see how to do it. Essentially, what we need to do is to think about it on a slightly deeper level. If you recall, with the Java Poet, we manipulated the Java sources. Now, we are going to manipulate class files, which are the binary formats. And it's not that frightening as it sounds. So, what we do, we take a Java class, we write a program, our own, and the output will be different Java class. Interesting. Recap. This is the code, the boilerplate code from Java Poet world that we really want to generate. Just a small recap from 12 minutes before. we have one class having one method. One of the ideas is to keep your classes short. You can fit them into the presentation and not overwhelm your audience. And yes, let's see what we do. Raw Java code, bytecode, is difficult to read and maintain because, as you know, it's a byte format. We are not get used to, as human beings, to think about bytes, even though some of us can. Let me introduce the ASM library, which was written in France about 12, 13 years ago. It's called ASM. It's extremely well-designed Java bytecode manipulation library and SDK. It's modular, small, and fast. And let me tell you another thing. All the cool stuff in Java that is really a black box for the most developers are built upon ASM. And let me, of course, give you a few examples. If you think about Clojure, who have heard about Clojure, the Lisp on the JVM? Excellent. Once you are back from the presentation, go and look in the Clojure source code, and you will see the ASM compiler inside. Who of you have heard about Groovy? Okay. That means we are doing good work to propagate the Gradle system. The Groovy compiler has a backend around ASM, and now we are going to see how. And of course, needless to say, most of the aspect-oriented frameworks for Java also use ASM because they have to do manipulations on method calls. Are you ready? So, ASM comes with a lovely, lovely tool. It's called Assimifier, that essentially it takes a class file as parameter and emits a source file, a Java file that we can read and understand and manipulate. I didn't say it's easy. And so let's look at the Assimifier output for our lovely boilerplate Java class having one method. Okay, that looks relatively user-friendly. Now the static byte signature, meaning a class loader, can trivially load it. It has a bunch of your ASM objects, which I definitely recommend you to read and to think about. Oh yeah, get ready. In all these lovely code lines, what we do is generating an empty constructor using the Java bytecode instructions. And now it's the right time for you to recall that every Java source file, without having a constructor, the Java C implicitly generates a default one, given the fact that we don't have any other constructors. And here how it's done. One of the greatest advantages of learning such tools, you start to understand how your system works. Usually the next step is to optimize it, but not the other way around. And essentially here what we do is we generate an empty default constructor. If you see the init and return void thing. And here finally we generate our lovely boiler code method, which is we visit the create method instructors. If you look, we have the string parameter of boilerplate method, and we have its signature. From the Java world, L Java lang string is essentially getting the string from the system, and the V following the braces is a return type void. And this is how types are translated on a class level. And then, once you have an access to such a fine code, you can generate your own, you can manipulate it. You can, for instance, change all method names in a single click, or add your own addition to every member, to every method. I mean, every method, every member, every field, every anything. This is how you achieve greatness that currently only saved for compiler writers. But for you and for us as Android application writers, is a good case for removing boilerplate code. Instead of struggling with this annoying code, just think a little bit and do some tool, I wouldn't recommend running to Java bytecode manipulation as a first step, but I would recommend to think about it, what you can do as an app developer to remove the boilerplate code. And yes, as we talked before, you must understand the class file format. But I also have the good news. It's not that difficult to understand. It's about 20 years in field, and there's a lot of good documentation around. And of course, as we said, not only bytecode generation, but also bytecode transform, say repackaging. No language limits, because if you think about it, in Java Poet, we are slightly limited by what Java-C can do. On a bytecode level, we have no limits at all. For instance, if something for you to think about, who have heard about the visitor pattern? I will use this question in my job interviews. And the visitor pattern is the limitation of Java language that doesn't perform dispatch on the parameter types. That's why we need to do a lot of method overloading. But you can write your own mini compiler for visitors using the bytecode manipulations, because there you got all the types, and there you can do your own dispatch. Isn't that cool? And yes, as we talked before, you must understand the class file format. And the costs are, we do have a difficult code to maintain. And the worst part, its code doesn't resemble executable. And sometimes, or almost always, it's a problem. But what I have found so far in my experience with a lot of Android and Java apps, sometimes it's much more easier and takes less time to develop some smart framework up front versus digging into a big mud of code, changing one thing and breaking 10 other things. Yes, that's happened. That's the nature of software engineering. So let's do some sort of a taxonomy of the tools that we have been talking about. And the recommendation is go from the easiest to the hardest. If there is a tool or the method that can solve your problem, go for it. Don't use your heavy artillery for the stuff that you really, really needs it. And of course, use it judiciously. So the easiest thing is, among all the tools that we have been talking about, is Java Poet. Essentially, not a lot of work required, not a lot of upfront investments. You can happily look at the Java Poet GitHub site, one dependency, and you generate programmatically Java. The next level is getting data from the program instance you are running. And the custom annotations here are excellent solutions. The next thing is, in order, as we talked before, for custom annotations to work, you need to use reflection. Reflection in Java, and of course it's fully supported in Android, is a little bit tricky. However, also something relatively manageable. And then comes the fun part. Who of you have heard about Jar Jar? Who have used Jar Jar? Okay, great. And as you already know, Jar Jar does the repackaging, and of course, it uses the ASM in the background. How Jar Jar does it? It does, of course, a lot of other useful work, but in the core of Jar Jar, there is a simple loop, as we have seen before, with the ASM call that changes every package name. Because package name, in the word of ASM, is just a string. And string can be programmatically generated and changed. If you don't know how to change strings, I think you are in the wrong conference. And of course, the ASM is the most difficult, requires upfront investment, but if you're there, you have absolutely no limits. Oh, the JVM word is yours, and a lot of cool stuff you can do in Android in this, even though I totally do not recommend doing it inside your Android apps. What we do recommend is do the things not in the runtime, but rather on a build time. As we talked before, to eliminate your boilerplate code and or to generate code. Using these tools during runtime usually means you have a problem. Because in the end of the day, your Android apps should be fast, should be easily testable, debuggable, and let's leave the complexity to the complex machines, such as build machines. Really, last time I checked, build machine has much more power than my new Nexus 6 device. So, me give you a little bit of real-world examples. Who have heard about DG2, dependency injection? Excellent. So, it uses Java Poet and custom annotations and reflection to generate dependency injection code in compile time. Again, when you have time, take a look at the sources. Excellent code to look at. And our friend Jaja, from 2 minutes before, as we talked, uses ASM to update the fully qualified names while repackaging. So I think this is the most important slide of my presentation. This is something that I really want you to get from this. That learning powerful APIs can assist you making wiser decisions and having better app infrastructure. So really, once you have a time, internet is really open. It has a lot of good stuff. It has a lot of good tools. Don't limit yourself to what you are using at the moment. Go, learn, spend some time. Your app, your users, your testers will thank you.